Well, hello, grade 10s. Today we're going to do something in physics called a practical. And this is one of the things that makes physics unique and fun. We get to play with equipment and we get to, we don't make bombs, but in this case, we're going to heat water. It's slightly more modest. And we're going to heat water in a kettle. And we're going to measure the temperature. And we have a digital thermometer attached to the computer, and the computer is going to measure the time and it's going to measure the temperature, and then we're going to draw a graph of what happens over time as we heat ice. So let's call this a practical. And it's got a heading. So when we draw a graph, we must always have a heading. So what is this all about? Well, it's called the heating of water over time. Something like that. Now, in our practicals, we have what are called variables, things that are going to change. So, for example, the time is a variable. And normally we put what we call our independent variable. Okay, so that's independent variable. That's the one we control. So time is, in this case, the independent variable. We put it on the horizontal x-axis. And then on the y-axis, we're going to put our dependent variable. And in this case, it's the thing we have to measure. So do we measure time with this, or do we measure temperature with this? No, we measure temperature as our independent variable. So, as our dependent variable. That's on our y-axis, so that is going to be temperature measured in centigrade. And please, if and when you draw this graph, we're going to have our origin here, naught. We're going to have time, naught, and then every 10 seconds we're going to measure the temperature. And then we're going to plot it over time. So say naught went there. And does it go? What do we expect? So we must have a hypothesis. Our hypothesis is really what we expect is going to happen. So the aim of the experiment is to see what happens to the temperature as we heat it over time. We're going to start with ice, then it's going to go to water, and then to steam. You all know that. But what do we expect our temperature to do? Do we expect it to wave around? Do we expect it to go straight up? Do we expect it to go straight down as we heat it? Do you expect the temperature to stay the same? So we're going to have a hypothesis, which is, I expect that as I heat the water, over time, it's going to get colder, hotter, stay the same. So that'd be your hypothesis. Okay, so we've got our two sets of variables. On this axis, we're going to have our time in seconds. So we put the seconds in brackets, just like we put the temperature, degrees centigrade in brackets. We must put our origin. Then we're going to have 10 seconds, 20 seconds, 30 seconds, 40 seconds, and it's going to go on. So maybe we'll give you a piece of graph paper to make this easier. Otherwise not. You can still draw, must be even intervals on your x-axis. And then we're going to start probably in the negative territory, minus whatever, and then it's going to go into the positive territory. So we're going to possibly start with our ice colder than naught, which is where ice freezes. So if you leave it in the deep freeze, the ice can get colder. So let's see what our starting temperature is, but it's going to start probably in the negatives. And then we must have at constant intervals, say 10, 20, 30, but we must have space for it. So this would be 20, 40, 60, 80, 100, 110, 120. Let's suppose we go up to 120 degrees, then this must be minus 20, minus 40 or whatever, but they must be evenly spaced, just like your time intervals must be evenly spaced. Okay, are we all happy with that? So we're going to then take some ice, put it in here. We're going to have a little stirrer, and we're going to keep on stirring it. Now, just bear in mind there are other variables. We can't sometimes stir, sometimes not stir, because there's certain things we must keep constant in an experiment. So you can't add more ice in the middle of the experiment or switch off the kettle. Once you start, if you're stirring, you must keep on stirring. Teachers, keep on teaching. There's a song like that. Stirrers, keep on stirring, and you're going to be measurers, keep on measuring. So luckily the computer's going to do the measuring for us, but you're going to have to take it down. You're going to put it in the table. So we'll show you in a moment. We've got a table prepared for you, and then you're going to eventually do a graph like this. The graph only counts for 5 marks, but it's 5 out of 30. So that's a good 5. Okay, and to get your marks, you must have a heading, you must have temperature in degrees centigrade, you must have your temperature going from 0 to 120 evenly spaced, and must go to about at least minus 20, minus 40 maybe on your graph, and then your time, 10, 20, 30, 40 evenly spaced. And I would suppose that this is going to take at least 6 minutes, so that's 6 measurements per minute, 36 measurements. Maybe 40, and so it should be all over in about 6 minutes. So let me get some ice, and then maybe we can get started. Right, so I've got a whole lot of ice here. There's our kettle. I've got chunks of ice. I just had to I had to froze a bowl of ice, and then I had to smash it up. So we got big chunks, little chunks. You know what? I suppose it would have been nice to have all the same size chunks. So it's called a fair test. I suppose in an ideal world, it would be pretty nice to have every chunk the same. So now we're going to stick our thermometer into the middle of that ice, and let's see what the temperature of that ice was that came out of the fridge, the deep freeze. So we're not going to close this. A fair test, everything must be kept the same, that must be kept the same, and let's just see what's happening to the temperature. So I'm going to share with you, and we're going to go to our program that is measuring the temperature, and let's reload it, and the time is going to then start at time 0. Okay, so I'm going to share with you the screen. You can't see a thing at the moment, so let's go to present now. My entire screen, allow. Then you should be able to see what I can see on my screen. Let's just see. So it says we are now presenting. So you should see me in, I think, a little box. And over here, you should see that it is started at 10 seconds, 20 seconds, 30 seconds. And look at the temperature here, minus 1.81. So at 40 seconds, it's still minus 1.81. It's going down a little bit further. Here is my actual computer program. It's all written on an Arduino Uno. And if I upload it, it's going to start again at temperature 0. And so I'm just going to start it again, and then it just makes it a little easier for you to record. It says here, temperature at 10 seconds minus 2.69. Right, so I think you can see me there now. And we haven't switched on our kettle. It's going down still to minus 3.06. I hope that we're all able to see everything on that screen. And when I switch the kettle on, the experiment is actually going to start. It doesn't matter if it starts at 30 seconds or whatever. You've got plenty of opportunity. Okay, so let us switch the kettle on at 50 seconds. Let's wait for it, 50-second mark to start. There we go. Okay, at 50 seconds, it's starting at minus 4.69 degrees centigrade. I'm going to try and stir it a little bit with, it's very hard to stir, and you can begin to hear the kettle sink. But you can also hear this ice. I'll tell you when the ice is fully melted. Look at the temperature, it's gone down even more. It's 5.18, 13 at 70 seconds. So we're going to stir this, stirring constantly. And now it's just a matter of stirring and taking measurements. Okay, so it's recording, it's presenting, it's minus 5.88. Stirring chunks of ice, very hard to stir, almost impossible. Still totally iced up. Still totally iced. It's going down, minus 6.06. Hey, the kettle's on, but it's going down. Did you expect that? I sure didn't expect that. That as the kettle's on, the ice is getting colder. Look at that. Stirring some more. Is it? Yeah, it's actually becoming a little easier, so that must mean the ice is melting. Oh, look there, the temperature went to minus 5.38. Still stirring, still stirring, still stirring. Hey, keep on stirring, teachers. Teachers keep on teaching, stirrers keep on stirring, otherwise you're gonna, whoa, there our temperature went to naught when I stopped. I can feel it's definitely getting easier. And look at that, it's temperature is 2.3. Oh, it's gone up to 4. Wow. There's still ice, you can hear it's got ice, but there's less ice. It's about half water, half ice. So I'm stirring, it's gone up to 5.19. Still ice. Still ice. But not much. Okay, so stirring, it's gone up to 8.94, time 160 seconds. I'm stirring. And there you can see the temperature's gone up to 9.30, 13.38. Still ice, I can hear it, but not much. You can hear it, still got a bit of ice. The ice is just about all melted. There's just one or two tiny little pieces. Just about all melted. Okay, I would say there is virtually nothing, but there are still one or two little pieces there. Now, from here on, we could say the ice is gone because we can't hear it anymore. So from here on out, we can say there's no more ice. So look, the temperature's gone up by 2 degrees to 19. It's gone up almost 4 degrees. We're on 260 seconds. It's now gone to 28 degrees. Wow, that went up 5 degrees in the last 10 seconds. 33 degrees. Obviously, it's all water. There's no more ice. 38. That was another 5 added. 43. Look how quickly that's going up. So I wonder what temperature this is going to eventually get to. So you can hear from the sound of it that it's not boiling. You can also see that there's no steam. And it's now sitting at 53 degrees, 58 degrees. I'm going to keep my fingers a little bit out of the way while I'm holding this cord, because I have a fear that at some stage it's going to get very steamy around here, and that we're going to have to be careful that we don't get ourselves burnt. 63.9, 68.75. Seems to be going up at a fairly constant rate with some hiccups here and there. So we're keeping on stirring it. Look, it's gone up to 73.44. You can hear the sound changing, that it sounds like it's getting close to boiling. It's gone up to 83. It's not boiling yet because there's no steam coming off. But I know the sound of this kettle. It sounds like the kettle's about to start boiling, but the water's not moving yet. Okay, now it's started to boil. Now here it is boiling, so I don't even have to stir it because it's stirring itself. And at this stage, the kettle would normally switch itself off. So it's gone to 96.94. Luckily, this digital thermometer can take a bit of heat. It can also take a bit of water. Look, it's gone from 96 to 98. Unless you close the lid, an automatic kettle will not switch off because it needs the steam forced down the stem here to switch it off. This is where the mechanism is that switches it off. So I know we're just going to let it boil for a while and just see. Look, the temperature seems to be stuck on 98 point, around about 98. It's not going higher than 98. And it's definitely boiling. You can see, I can see water being occasionally chucked out. Gone to 98.94, then it went to 99, 99.06, but you can see it's more or less stopped going up. So it was rising by about 4 to 5 every 10 seconds. That is 1 degree change every 2 seconds. But now it's just stopped at 99 point. Okay, it's just 99. And we're boiling and boiling away. Okay, 99. I think we're going to get the point now. Us humans are pretty good at getting the point that nothing's changing. And while it's boiling, it's just going to boil at 99.06. Okay, so I'm going to switch off, and now we're no longer adding any more heat to the experiment, and the experiment is going to stop. I wonder if the temperature will go down after we switch off the... No, it's still at 99.06 after we switch off the kettle. We don't want to leave our thermometer in too long, but I just want to see if it comes down at all. Yeah, it went down 1 degree already. Okay, but the experiment has basically ended at this stage. At time 500 seconds, the experiment ended. 500 seconds. Okay, I'm going to allow you to get the temperature here. And you know what I'm going to do? I'm going to go and copy all the temperatures. So let's go down to here. Okay, and let's see if we can copy all of this. Let's copy all those temperatures. And let's put it somewhere into, say, here. Let's just see. No, it's not pasting there. But anyway, I've got them copied. I'll try and find a place where we can copy this to. Maybe we'll make a Google Doc or something, and docs.google.com. Let's just see. A new document. Let's see if we can paste our data into there. No. Let's go back. Doesn't seem to have copied. So sure you can copy from this program, terminal window, surely. There we go. So now it's copied. And we started at 50 seconds and then it goes all the way and we ended at 500 seconds. So we don't need those last ones were after the temperature. You can see it, the temperature came down, but this is actually where it ended. And at 50 seconds was where it started. So we're going to allow you to copy all this data down into, let me just show you, we have got we've got the practical. Do you see here's the practical? We borrowed it from another school, but we're going to use the same practical. It says here, take a thermometer and freeze it in a container filled with water. Well, what we did was we took chunks of ice and we removed it from the freezer and we take readings on the thermometer. The freezer, once the temperature reading is between -9 and -5, well, ours was started at about -5. And then we started at 50 seconds, and the temperature at 50 seconds was, and we will write it in there, and then goes on and on and on, and ours ended at 500. So we've got plenty of space to put in the temperatures. We'll allow you to do that. Then we've got to draw a graph to represent the data recorded in the temperature above. How would the graph differ if you used crushed ice instead of a solid block of ice? Okay, so you've got to think about that, and then you've got to come up with your answers. But now to your teacher and I myself will have given you this practical page, and now you're going to start from, we started at 50, you're going to start putting in your data. So let's just go back to the data. And so you're going to, I'll leave this on the screen, get your results. At 50 seconds, it was -4. At 60 seconds, -5. At 70 seconds, -5. You know what? I don't think I honestly don't see the point of putting the point something. So I would say what you should do is, if it's -4.69, just make it -5. Anything that's above, so if -5.63, I'd make it -6. I'd make that -6. It's going to be too hard to plot it otherwise. This is -6, -6. This is measured in decimal, so it goes up to, surely this is decimal. Yes, it goes up to 23.94. So if it's above 0.5, take it to 1 higher or 1 lower. And if it's below, like 2.3 is just 2. 4.13 is 4. 4.5, now that's exactly spot on. I'd make that 5. 5. 8.9, I'd make 9. 9.3 is 9. 13.38 is just 13. 13.56 is 14. 13.56 is 14. 14.94 is 15. Yeah, 15, because it's closest to 15. 17.31 is 17. 19.75. So what is the rule? If it's greater than 0.5, make it the next degree up. If it's less than 0.5, keep it at the same, 17. That would be, it's greater than 0.5, so that's 20. That's greater than 0.5, so that's 24, 28, 33, 39, 43. Look, that's greater than 0.5, 49. Okay, so forget the decimal, just round it off so that we're just working not to any point something. Frankly, you could copy it down like this, but when you graph it, you're not going to be able to graph 5.19 because your graph's not going to allow that. So you might as well, to make your life easier at this stage, you might as well just round these up to whole numbers. Okay, so I'm going to allow you to take this down. The teacher can stop this and you'll be able to get those temperatures. And then I'm going to move. You could stop this because it's going to be on YouTube. You just press the space bar, and then there's the next lot of readings. Just press the space bar and it'll advance it, and then goes to there. You can just pause it by pressing the space bar. Press the space bar again, it'll unpause it, and we ended at 500 seconds, so it's, or 510. There we go, it ended. Okay, so there you've now got your readings, and I'm now going to see if I can hit the record button and stop this recording. Let's see. We've got to go to Safari. Yeah, we're presenting to everyone, and we're going to hit the stop recording button and put this on YouTube. So let's hit stop recording.